Here at Southeast Community College, we have chosen the LabView software as our control system for integration into our physics and engineering labs. This software was chosen because of its versatility in incorporating specific ideas into the lab where students did not have to concentrate on data collection, but could spend more of their time viewing the real-time graphs that they generated while they're taking the data, and hopefully emphasize how they would learn physics and engineering better. New VIs are written for each of the labs. Each one is specifically targeted to match what the students are covering in their selected topics and are designed to emphasize particular ideas that students are to pay attention to. Many of these VI examples are multiple graphs or collecting data over very short periods of time, as you can see in both of these examples. The example used to illustrate how we use LabView is our phase change of ice experiment, where LabView is used to control a heat pulsar and monitor a thermometer registering the temperature of the ice and water mixture. Students become quickly familiar with the VI. In this example, they are melting the ice and they are using the computer to control the heat pulsar while they monitor the temperature of the water in real time. Here they begin graphing. The VI is written in such a way that it will turn on and off certain parameters that are preset. Here they control the heat pulsar by a button on the VI, and it also tells them then the amount of heat being added during this experiment. With LabView controlling most of the data collection and turning off equipment, the students can spend more time actually evaluating the graphs in real time. This allows them to monitor exactly what's happening as the experiment is taking place without having to worry when to turn on and off key elements. Here the students begin melting the ice as heat is added to the mixture, and they can see the graph as the water and ice mixture receive the heat. As the students continue to monitor the experiment, what they notice is that the temperature is not increasing very dramatically. An experiment that they would have run earlier would have shown how the water temperature would have increased quickly as the same amount of heat is being added. The students can easily see the graphs as the lab continues on. All they have to pay attention to is the continuous stirring and monitor the graph as it is being developed in real time. Another key feature that we've incorporated into a lot of the VIs is to put indicators on the graph where important events happen. In this case, the students are told to monitor the amount of ice, and when the ice begins to completely melt, that they can use the indicator or the button to activate a marker on the graph. This marker allows students to go back and look over the graph later on after they've completed the experiment, and it reminds them exactly what was taking place at key events in the experiment. Here you can see the marker has already been placed, and now the students also notice a difference in terms of the type of graph that is being produced in this experiment. Again, it continues to monitor the heat that is being put into the experiment, and the students will continue on until the VI automatically shuts off the graphing and the heater at specific temperatures that have been predetermined and put into the VI. With the experiment ending, LabView has shut off the heater, and the students just have to decide when they turn the graphing off. Once the graphing has been turned off, everything that the students need to conduct the data reduction is still on the graphs and can be used as part of their analysis to determine the latent heat of ice. The students can examine the graph and its temperature at any given time using the cursor and the interactive part of the graph. As they monitor the beginning and final temperature, they can also use the heat added and determine the amount of latent heat needed to melt the ice. This is one example of the 75 VIs that we've written for use at Southeast Community College.